Let's apply Newton's third law to accelerating blocks. In this particular problem, these blocks are experiencing a force of 42 newtons on this frictionless surface. If blocks A, B, and C experience a force of 42 newtons, what acceleration do they experience is the first question we'll answer. Then what resultant or net force does block B experience? And finally, what force does block B apply to block C? Remember, we always have to apply all parts of our force toolkit. So going back to the first question, if blocks A, B, and C experience a force of 42 newtons, what acceleration do they experience? So our first step is always to identify the accelerated system. And in this case, the accelerated system is all three blocks A, B, and C. Step 2 is to identify the coordinate system, and we'll say that to the right is positive. Step 3 is to draw a force diagram, and in this case, the blocks themselves are on a frictionless surface. So the applied force is the only force, and it's pointing to the left. Because there's only one force and it's pointing to the left, that means we have to have acceleration pointing in that same direction. So that means the velocities are increasing to the left. We write down Newton's second law. We plug our values in, or our forces in, from our force diagram into Newton's second law, so that Newton's second law now says that the applied force is equal to the mass of all of the blocks times their acceleration. So we plug in our values. We make sure that when we plug our values in, we have the correct signs. Because the 42 newtons is pointing to the left, we need to make sure we put negative 42 newtons there. Now, the mass of all the blocks is 7 kilograms. So if we divide both sides by 7, we get negative 6 meters per second squared. The next question is, what resultant or net force does block B experience? Now, this is the total force. That's what they mean by a net force. So we once again have to identify our accelerated system, and it's only block B. Our coordinate system doesn't change. The right is still positive. Our force diagram doesn't change. We still have the same force diagram. However, this is only a force diagram with respect to block B. Then we draw in the motion map, which turns out being the same, Newton's second law, and we plug our forces back into Newton's second law. However, this time we notice that we were only using block B. We know from the previous part that all of the blocks are experiencing an acceleration of negative 6 meters per second squared. So that's the value we'll plug into that equation. So we plug in block B as our value, and we know that the acceleration is negative 6 meters per second squared, so we get a net force or a resultant force on block B of negative 12 newtons. So the next question is, what force does block B apply to block C? Well, this is a third law problem because there are actually two different systems. The first system is a normal force of block B onto block C. And that's what this looks like right there. Okay? And the next system is the normal force of block C onto block B. And that's what that looks like. These forces are equal but opposite in direction. Next, we look at just one of the two systems. So let's use the force of block C onto block B. The acceleration is the same for all the blocks, which means that all 42 newtons accelerate all 7 kilograms. How much of this force is transmitted through block C to accelerate blocks A and B? Well, that's where step 1 is so important. we have to use blocks A and B because both blocks are effectively being accelerated by block C. Our coordinate system doesn't change. The right is still positive. Our force diagram doesn't change. It's still the applied force, but now we're only applying it to blocks A and B. Our velocity and acceleration motion maps look similar. We still write down Newton's second law. But now in step 5, notice that we're only using the mass of objects or blocks A and B. So in step 6, we would then write out and plug in our correct values. So since we're using blocks A and B, that would be the 1 kilogram and 2 kilogram blocks. And so our mass is a total of 3 kilograms. All the blocks are experiencing a force of negative 6 meters per second squared. So our total force is negative 18 newtons. Now that applied force, remember, is that negative 18 newtons of force is the applied force of C onto B. So the force of C onto B, which is a normal force, is negative 18 newtons. That's this force right there. But we decided earlier that the normal force of B onto C is the same as the normal force of C onto B. So this is a Newton's third law problem, and from that we find that the force of B onto C is a positive 18 newtons.